So I think we stopped into this slide whenever I was discussing this thing. Then I could not show you the exactly the energy content there, like how I got this 4650 and other things. I think I have the table now. So the table that I have is basically let me see, where is the table. So I think this table is somewhere around here. Yeah, here is the table that the food waste has a typical energy content is 4650 kilojoule per kg and so on. So that's what I got the data for this one. So anyway, we'll start from this slide now, chemical content. So represent data on the ultimate analysis of typical municipal solid waste components are presented in the table in the next slide. The energy values are not available. Then you can take the approximate value from the table. So the equation that we are using, this equation is basically known as modified Dulong formula, and the data in the table in the next slide. So where C is the carbon percent content in percent by mass, H is the hydrogen, again everything in percent mass, hydrogen, oxygen, and the sulfur, all of those. So here is the table that shows the typical data, ultimate data, and other things like food waste. Carbon would be 48%, looks like 88, and hydrogen 6.4. That means there's nitrogen and so on. So that's the dry basis. These are percent, but dry basis. Okay, so we can use this. In this case, I don't think I solved any problem using this equation, but this gives you an idea of we can do that. I think I do this one in C4343 more detail with some other additional equations and other things. But anyway, so this next one category is the industrial waste. Industrial waste are those waste arising from industrial activities and typically include rubbish, ashes, construction, demolition and debris, CDD, special waste, and hazardous waste. So construction waste, I'm not going to read all of those here. These are very easy to read, and I have those in my class note. You can read it. The construction waste that come from the construction activities, ash or bottom ash. Ash and bottom ash come from burning. Like say if we burn solid waste, if we burn coal and everything, then we generate two kinds of ashes. One is the fly ash, other one is called the bottom ash. So bottom ash basically settle in the bottom. The fly ash, usually they use some kind of capturing mechanism. When it is trying to go away to the atmosphere, they capture those and separate those in there. They call it fly ash. So there are a lot of usage in the fly ash and other things too. So, but in this case, we are just considering the bottom ash for the purpose of solid waste incineration. Okay, special waste. Solid waste that are difficult to handle due to its physical or chemical characteristics require special precautions because of hazardous properties or nature of the waste creates waste management problem in MSW operations. Special waste include but not limited to foundry sand, metal scrap, drums, empty drums, PCBs, leather straps, non-MSW and non-hazardous waste one, street sweepings, roadside litter, catch fish and debris, dead animals, and abandoned vehicles. So these are the one industrial, but these are kind of considered as a special waste. The next one is the hazardous waste. Waste that pose a substantial danger immediately or over a period of time to human, plant, and animal life are classified as hazardous waste. Other definitions are provided in topic 8. So we'll discuss this one in topic 8 more detail. Okay, then the next one is the medical waste. So I'm not going to read all of those. The medical waste are the one that generated in the medical facilities, clinic, hospitals, and other things. So, and more is continued on the medical waste because it's very important. Different materials, different part of it, they have to manage different way. Universal waste. Universal waste, basically there are 4 types of universal waste. Batteries such as nickel, cadmium, and small lead acid batteries found in electronic equipment, mobile telephones, and portable computers. Agricultural pesticide that have been recalled or banned from use or obsolete. Thermostats that contain liquid mercury, and lamps that contain mercury or lead. We cannot fluorescent bulb, right? Fluorescent bulb. So universal waste is a kind of hazardous waste, but the waste that has a potential for recycling usually demarcate as a universal waste. So details will be discussed in topic 8 for that, hazardous waste category. So CDD waste, as I said, is come from construction, demolition, and debris. So it's very easy to understand that. So I'm not going to read all of those here. So radioactive waste. Radioactive waste are specialized category of industrial waste. The main generators are electricity producing nuclear plants, nuclear waste reprocessing facilities, nuclear weapons facilities, etc. Radioactive waste are also produced by research and medical procedures, some of the cases, X-rays and other things. Energy is generally released from the nucleus to convert into some stable form. Energy can be emitted as a particular magnetic waves. Particles include alpha and other things like that. So the particles include alpha particles. These are composed of 2 protons and 2 neutrons, the equivalent of helium atom and things like that. So these are the one, due to these activities that something become radioactive. So it's more on the radioactive, mainly alpha, beta, gamma rays. So gamma is the main one that has a more power. In the X-ray, we use those in this case, right? So you guys are familiar with the X-rays. So X-rays is done due to the gamma rays, high energy power, high energy beam passed through the system and other things like that. Mining waste, so that the coming from the mining activities. So I'm not going to read all of those, so you guys can probably read a little bit in there to explain it. So agricultural waste that comes from the agricultural activities. I should mention over here that most of the solid waste management regulations are not applied to agricultural waste because the agricultural activities are exempt from the solid waste management regulations and other things. Some cases, some of them are definitely yes. It is unregulated. That means it's regulated but exempted from the solid waste management regulations. So then the next topic is the solid waste generation. So solid waste generation is very important to know because we have to know how much we are generating so we can be ready or we may be ready to manage it, right? Those activities in which material are identified as no longer being of value and are either thrown away or gathered together for disposal. So typical unit waste generation rates for municipal and selected commercial and industrial sources are reported in different tables. But generation rate data are not available. The data presented in the table can be used for the purpose of estimation with reasonable confidence. So here is the generation perspective. So the picture that I have over here, it says that in 2000, so generation was 232 million tons before recycling. So here it shows different percent and other things. Okay, so here this one it shows 2010 generation of 250 million. So it is in 2010 looks like. So this is also before recycling. So trend basically here I'm explaining a little bit of trend, meaning like say how it's increasing and decreasing. Probably is better to show in terms of the curve. I think that I have the curve over here. So this curve can give us the option of like say to the 1960 to 2015 the generation rate in million tons. This is in million tons per year, right? For 15 was 262.4 million tons. And these are the ones basically per unit, per capita generation, pounds per capita per day. So in 2015, looks like 4.48 pound per person per day in the USA. And so on. Average 4.5 can be estimated because I have more here. Sometimes when I calculate something based on I do use 4.5 pound per capita per day as a value. So now we are going to solve this problem to understand the perspective of solid waste generation and management. So this is a very interesting problem. So how long will it take in years to fill the state of Georgia with a 25 feet depth of solid waste? The waste will come from all over the USA with a population of 312, 475, 745, 538. I think this is the population. I don't know exactly. I'm just assuming the number. Mainly, this number is good. If I say 2010 census, it would be 308, 745, 538. So anyway, assume average solid waste generation rate as 4.5 pound per capita per day, bulk density of solid waste as 800 pound per cubic year, and the area of the Georgia is 59,425 square mile. So these are the data that we have. We'll solve it here. So I use the Excel to solve it. Here is the given population. The generation rate is this, waste depth is this, density is 800, Georgia area is this. So I converted into pound per cubic feet. So it was pound per cubic year. I converted into pound per cubic feet, and here it is square mile. I used some conversion to calculate it in the square feet. So amount of solid waste generated. So this would be like, say, whatever, 4.5 per capita per day multiplied by this. This would be 140 million pound per day, because I multiplied with population with this. Then 365 a day equal to 1 year. So that means 5.14 10 to the power 11 pound per year. Then the volume of the waste is equal to cubic feet per year. So I didn't show you all the calculation, but since I know the pound per year, so I can probably just do this. So this is pound per cubic feet, and this is pound per year. So then I should be able to do this. This divided by this will give me, this is the cubic feet per year. Area to be occupied by 25 feet waste is equal to this. So 25 feet, because how I get this one? So I did this divided by 25 is equal to, this is what, like, say, I think it's 693,474,130 feet square per year. So therefore, time required to fill Georgia with 25 feet of waste is equal to this. I didn't show you the calculation. So in this case, this is a square feet per year. So, and this is the square feet. So this divided by this will give me 2389. So this gives us a little bit of perspective, like, say, how many years? It looks like 2400 years will take to fill 25 feet of waste into the USA, the rate which we are generating throughout the USA. So you see, only if we even can compact it, half of it, then it will be 1200, right? 1200 years it will take. So anyway, this can give us a little bit of perspective of, like, say, how important it is for the management of the solid waste. Okay, I'll keep it in the screen for a few seconds so you can take a look on that. Okay, so here is the one that shows a trend, because I used more data. This is the plot I did, and I think that's what things like that. Okay, then next one we'll do the estimation of solid waste quantities. There are two different ways we can estimate: load count analysis. That means in this method, we can count the number of load coming to a landfill or transfer station. The total mass and mass distribution by the composition is determined using average density data for each waste category. And the second option that we can use, mass volume analysis. This is similar to the above method with the added feature that the mass of each load is also recorded. Unless the density of each waste category is determined separately, the mass distribution by composition must be derived using average density values. We use a table. You remember the table that we have? We may be able to use it from there. So the factors that affect the quantity of MSW are geographical location, season of the year, collection frequency, use of kitchen grinder, characteristic of populace, extent of salvaging, recycling, public attitude, per capita income, size of the household, population density, and legislation. These are the factors that affect the quantity of solid waste generation and management. So, on-site handling, storage, and processing. Those activities associated with the handling, storage, processing of solid waste for net point generation. Depending on the type of collection services, it could be defined in different ways. In high-rise apartment buildings, waste are picked up by building maintenance personnel, porter, and each taken to the basement by the tenants, or bagged and placed in tenants and specially designed chutes with opening located on each floor. So this could be another way to manage it. So further, in most office, commercial, industrial buildings, the management can be done different ways. The large storage containers, I have seen those in the apartment complex, compactors used in conjunction with storage containers, stationary containers, and other processing equipment such as incinerator. So these are the one can be used. So I'm going to stop here and we'll continue from